Hi there, Rigo here. So, are you in need of a new power supply? You need something with more amps than usual, but you can't spend too much money and you want something customizable? Well, this video is for you. So you're starting out, or you're in college, or maybe you're more advanced in electronics, but you cannot afford, those really pricey power supplies. These ones here are not good enough for you. These are great actually, they are digital, but still they don't have enough power for your type of experiment you're doing. And of course, if you want to do the real professional models, you don't have the money. Maybe your project requires, high power supply, 20 amps or, 20, 30 volts, but you don't have the hundreds of dollars required to have a good power supply with low noise. Maybe like me, you're working with RC. You have some RC models, some drones, or anything that is portable, embedded runs or batteries, but you don't want to keep cycling your batteries to test the equipment in your lab. And of course, designing a power supply from scratch is kind of a hard challenge, especially if you're a beginner or you're focusing on firmware, testing, automation. You're not doing a specifically hardware design. Well, I made this mission of helping people make their own power supplies, and all started 2 years ago with this video, my second video about building a maker lab. And this is the first, iteration of my do-it-yourself power supply with a, switched mode power supply with a fixed voltage and a power buck converter. So let me show you the older model and then show you the newer model so you can understand what changed from one another. And let me just tell you, the newer model is cheaper to make, is simpler to make, although it has some noise because we are doing two converters in series. The new model is much easier to build and easier to maintain, and it performs better. So let me jump to the lab bench and I can show you the older model compared to the new, and then explain to you my decision making and how to actually I got the models I'm going to suggest to this project. So welcome to my secondary table, and this is a new setup, so I don't know how video and audio are coming through, but I hope you can understand everything quite clearly. So as some of you remember, this is the ugly duckling of the house. This is my first do-it-yourself power supply, and it has tons of problems, but it's my first time doing something this complex, but ugly casing because I didn't have the tools I have today. And you can see I was doing my best to make air circulate inside the module. It is completely analog, so this is only a display. It actually won't control anything. You set both things by these pots, voltage and current, but to read the current you need to use a powered load to short the whole power supply, and then measure the current is working. So fully analog, as if you want you can check the video. And you have one switch to turn the switch mode power supply and one switch to turn on the outputs. This is not the way to do it, especially the switch one, and LEDs to indicate stuff. But some ideas here are already quite great. For example, having active cooling system, it's perfect, and having cable adapters so you can have the cables out, that is actually a good idea, and fuses, always great. So I wanted something better than this, especially the control part. I want something digital that I could set the current and voltage with an encoder, much easier to do, interface wise, and also a way to turn this on and off without a switch, actually having a solid state switch. So I looked for solutions, and this is when the new power supply comes into play. So I present to you the new power supply. Let me just put it here in front of the camera. This is an ammo box. This is a 50 cal ammo box, and now you can see I have proper cutting and drilling tools. So this looks much better, much more presentable, and it has a digital controller. So the buck used in here is not only a more powerful buck, but everything is digital. So turning on and off, it's done, solid state switch, and I can control everything with an encoder. So this entire project is based on a better buck module that is only digital, but supports higher amps. And one thing that this accomplishes no, besides looking better, being easier to make, is the fact that the wiring on the old power supply is nasty. This one much simpler. Let me show you the old power supply internally and you can see the evolution. So this is the power supply, the old one, and take a look at this rat's nest. Here you can see different power supply for the fans, and then the old buck that I have to jump the potentiometers, and then this mess in the front. This is not looking that great. I know, it was my first project and I was a rush to have a power supply in the house because I was in dire need. All that, wood case, and you know, everything is analog. You have the voltage switch in there. You know, this is the first iteration. It solved my problems and I used, and it worked really well. But now I have something much more capable and bulkier. This is a 50 cal ammo steel case, which by the way I can remove the leads. Let's not take the wire back. And inside, okay, it doesn't look that better, but it looks better. So you have an AC cable that runs up to here. Let me just show it back in the camera. There you go. A pair of cables, pair of wires from the power supply, and then you have the buck converter and a pair of wires to the front connectors. So comparing to the other, this one has a compound connector here, so you have better cables. They handle better currents and it's a standard cable. Already has a fuse in that. The fans are smaller, so I wish I could make them bigger because they make more noise. No, the smaller they are, less efficient. But this one supports 20 amps and built-in XY6020L connectors, so you can connect your drones and RC planes directly to it. So everything here is based on the buck converter I chose. So let me show you how do you choose, or how do you make your own power supply choosing your own buck converter. So this project actually started 1 year ago, you know, a little while after I had the first power supply made, and I wanted the same kind of project, you know. You have AC, you know, alternating currents. Let me get this closer to the camera. Yeah. So I wanted a switch mode power supply in here, give us a fixed voltage, and then I wanted a regulator that, you know, from that voltage could, you know, step up or step down, so I can control, have variable, you know, power supply. And I also wanted everything to be digital, so I could turn it on and off and set the current limits and all that. So it all started 1 year ago, and I got that ammo box, the case, and I got the components. So I went out to find a converter. So this guy here is key. This is the heart of the project, and it defines what kind of power supply you need based on what kind of loads you have. So you could go step up or could step down. This is a boost converter, this is a buck converter. Boost converters usually don't go, you know, downwards, they go upwards. So you have a voltage, they'll step up, and the range will be upwards to twice, thrice, many times the voltage, but they never go lower. And that's a problem. I want a power supply that can use down to 3, 2, 1 volt. So buck converters are much easier to get small voltages, and at the same time current here is usually the same, because circuits that made high voltage are easily to do, but circuits that go, you know, from, you know, AC to a high amperage power supply, those are hard, you know. High amps is hard to come by, so these both usually have high power ratings, but the same limits on 20 something amps. I went on the buck converter. I decided, okay, I want low voltages, so what kind of module can I find on the internet that has really high power? And that's everything I needed to find. So the entire project is based on this module, the 60 volt 20 amps, you know, buck converter. I don't have 60 volts switched mode power supplies here in my house, so I went for the 48. So my power supply doesn't go up to, you know, the 1200 watts, but it goes up to 900 and something. So this is already great, and you can find this module by its, you know, IC name that they use on the, especially on AliExpress. So you can see there the module is called XY6020L, and this is basically a buck converter, but a really powerful one. And this module, you know, has an output power of up to 1000 watts basically. All I care here is the ripple and the output current, and the current goes to up to 20 amps, so that's amazing. Output voltage goes up to 60 volts. Unfortunately, my switched mode power supply I had in my house was 48 volts, so that's our hard limit. You could go up to 1200 watts. I won't, because I didn't have access to such a high voltage power supply. But that's my choice here. I could, you know, spend some money, but I wanted to save some dollars, so, you know, I got the buck converter and used a switched mode power supply I had at my house. But the key thing here is it has an overcurrent protection. Default is 16 amps, you can go up to 20. And everything is digital. You can turn it on and off the loads, and you can regulate everything digitally. It shows the watts and internal temperature. More details, you can find a link to this product in the description of the video. So before jumping to the demo, let me just show you these parameters they show here in the distributor. All kinds of protections, so this is amazing, especially short circuit protection. It turns off the power supply. But the important thing is it has kind of a big ripple voltage in there, and you're gonna see in the tests, and it goes, you know, it gets bigger than 100 millivolts, but it's really powerful. And usually you're not looking for the most clearest power supply when you're dealing with 1000 watts, at least not in the range of the price here. This regulator goes up to 20 something dollars, and the power supply you can get for like 40. So with $65 and a few bucks for, you know, a case and some wiring, you can get a really powerful do-it-yourself power supply at home. With the only caveat being it gets noisier, because I'm getting a switched mode power supply and putting, you know, a switched mode regulator in series. Noise here is your enemy. But I'm gonna show you a demonstration where it gets really noisier, and at the same time show you ways you can actually filter that, or use, you know, an LDO if you want, you know, a clear signal without making another power supply in your lab. So before jumping in the test, let me explain this really weird load I have in here. I don't have power loads in my house. I have some motors and anything, but I have to wire everything up. So I got some power resistors here, and I'm actually really proud of what I got here, because they are different power ratings. Like these two are 50 watts, these are 100, these are 1 ohm, 2 ohm, and 10 ohms. And I actually got a circuit here that I can get the maximum power rate, or really close to the 500 watts theoretical. They're gonna get 580 or something like that. So this is my load in here. I didn't have anything more powerful than that I couldn't arrange, but it's gonna drain up to almost 500 watts. This is a really good demo. And another thing that I have to tell you on this demo is gonna get noisier, because this guy doesn't have fan control. So let me lower this, reduce the noise. I'm gonna turn this on, and I'm gonna turn this power supply on, set to 30 volts, and we are expecting here some 16 amps. And then you're gonna analyze the noise. I'm gonna pause the output because it gets the loads really warm. So my oscilloscope is already on AC mode in here, and let's turn this on. First, the main switch. I told you it gets noisier. And now I have 30 volts, and I'm gonna turn it on, capture, and then turn it off again, so we can have a silent simulation. I can analyze everything without warming up my entire room. Here we go. So that was, if I got it correctly, 450 watts. So we almost got into the maximum power I could get with a setting like this. They are already warm, and we can analyze this noise. So this is not as bad as you would expect. We are drawing 500 watts from this do-it-yourself $60 power supply. It was made basically the electrical part in like 2 afternoons while I was working. And we are not counting here the months it took me to, you know, get the tools to cut and make holes in, you know, 1mm sheet steel, but let's all ignore that. So my oscilloscope here is in 100 millivolts vertical axis, and this is the general situation you get here. And the peak to peak is 370 millivolts. That's a lot of noise. But this is for 30 volts. Let me show you the full range picture so you see that this is not as noisy as you would imagine. Let's turn this on again. Very loud. But as you can see, when you put it in perspective, for 30 volts you have 0.3 volts as noise. That is not bad for such a powerful power supply. If you get lower loads, you want to use this for a microcontroller or something like that, yeah, I would recommend doing some filtering or using an LDO. But if you want a high power supply, do it yourself, easy to assemble, only 2 parts, that goes up to $70. This is an amazing project to do. And if you need a low noise output, but you don't want to build 2 do-it-yourself power supplies, I would recommend to have like a dedicated module with an LDO. But if you want to make like an add-on, one add-on, something like a DLC for your power supply, you could make just a connector like this. And don't bother with the color, I know it's inverted, no problem. You can have like XT60 or banana connectors, and you can just connect this to an LDO, an adjustable LDO, for example, an LM317 or something like that. So you have a really cleaner output for microcontroller, embedded, something like that. And you still have a powerful power supply to power, drones, RC, or if you're into physics, a lot of experiments need, higher currents with, a lot of power to put in. You can use this to charge batteries, you can use this to do electrolysis, you can do metal coating, plating, stuff like that with a do-it-yourself, simple to build power supply. So, thank you for coming to another Rego Lab video. I hope you found something inspiring, help you make power supplies to your lab. If you have any comments on my project, I know this is a very simple project and really crude, but it's helped me a lot with my more power hungry projects. Leave a comment down below. I will do my best to keep the 1 video per month schedule, but during a master's and a lot of things happening in my personal life, this has been a real challenge. Anyway, I hope you learned something. I hope this video inspired you making your own power supply, one way or the other, without paying hundreds of dollars for a new professional power supply. If you're starting or you're a maker like me who works at home, you don't need all that money to be spent on that. You can save that money for something more expensive, an oscilloscope, for example. And I'll see you on my next video, hopefully before the end of the year. See you there. Bye bye.